There is a basic bracket designed to support an electric motor that has an average weight of 150 kilograms. Our objective here is to find out, based on these three different designs, which one is best suitable, in fact, which one is safer to use based on the parameter or the load that will be exerted on it. First, we consider this first bracket. Let's go to the Environment tab and go to Stress Analysis. We click on the Create S.T.E.D and select Static and OK. We'll assign material to these brackets, and the material that we are going to use here is aluminum 6061. So we have this. Okay. The next is to apply our constraints to these brackets and select the area that will be fixed to the wall. The next is to select the load, which we are going to select the force and apply a force of 150,500 Newton, because the weight or the load of the motor that will be placed on this bracket will have a weight of 150 kilograms. Apply. Then we go to our mesh and mesh it. The next we have to do is simple to simulate it and find out what is happening here. The maximum load or the maximum load applied is of course 150,500 Newton, and as a result we are having a maximum vorticity stress of 575.3 megapascal. Let me click on the minimum and the maximum load vorticity stress, where the stresses are maximum and minimum. Okay, so this zone indicating the red tells us that these are the areas that is more concentrated to stresses, and that if there will be any failure, this is the area that will occur. And also, looking at the maximum load to be 575.3 megapascal, there is one thing we have to consider here. The yield strength of aluminum as material is within the range of 250 megapascal to about 475 megapascal. And so if we assume the maximum yield strength of the material to be 475 megapascal, and at the end our vorticity stress is showing us a maximum value of 575 megapascal, this simply tells us that it will fail, in the sense that the stress is more than the yield strength, which is not safe for the material to withstand the load applied on it. If we move on to the factor of safety, or the safety factor, we are going to realize that the minimum factor of safety we have here is 0.48, which is way less than 1, or which is way less than 1.5, and that is not safe. So with this design, we have understood that the vorticity stress tells us that the maximum is more than the yield strength of the material, and secondly, the factor of safety is also less than 1.5. That is for this design. Then let's go to the next design. We are going to consider the same material and the same load. We'll go to the Create S.T.E.D, select Static Analysis, and OK. Let's assign material to be aluminum 6061 and constraints and fix displays, and apply the load of 1500 Newton. Okay, let's mesh it and let's simulate. Right now we are seeing that with this design, our maximum volumetric stress we have here is 100.2 megapascal, which occurs somewhere here. So it also means that if there will be any failure, it will occur at this particular edge. And of course, the load or the stress you are seeing here, that is the maximum stress to be 100.2 megapascal, is less than the yield strength of aluminum. And so we can see this material is a bit safe. Now furthermore, let's look at the factor of safety and see what is happening here. Yes, we are saying that the factor of safety here is more than 1.5, which is 2.74 as minimum. And that we can see, yes, this design is safe to be used based on the parameter or the load that will be subjected to it. Now let's go to the third one. We have this. Let's click on the create, static, and OK. Let's assign material aluminum 6061. Let's fix this. Of 1500 Newton. Mesh. And simulate. All right. Over here, we are seeing that the maximum volumetric stress here is 168 megapascal, which is also less than the yield strength of the material. Let's go ahead and find out the factor of safety. The factor of safety here too is more than 1.5, and so this is also safe. So based on these three analyses, the factor of safety is 1.64 with a maximum volumetric stress of 168. This with the factor of safety of 2.74 and the volumetric stress to be 100.2 megapascal, and this with the maximum stress of the factor of safety to be 0.48 and the volumetric stress to be 575.3 megapascal. Okay, in conclusion, the first design, which is this, is not safe because the stress is more than the yield strength of the material. That is one. Then secondly, the factor of safety is less than 1.5. And so this material or this design is not safe for the load that will be exerted on it. These two materials are safe to be used, but if you are to select one, this one with a factor of safety of 2.74 is safer than this design that has a factor of safety of 1.64. All right. So what is your view? What is your point of view? If there's anything that you have to contribute to this, I'll be glad to respond or reply to your comment. Thank you.